we had a little bit of a thing that we found in the factors. So the slides will be a little bit different what I'm showing than what you'll see on the web, but we're fixing that while I'm talking, so it'll be fixed very soon. All right, but we're going to talk about factors for a bit. And we talked a little bit about how sometimes we have character variables that have an order that has meaning. And in that case, we're going to want to think about factors. Factors can also be helpful if we have a character variable that maybe there isn't a particular meaning with the order, but we just want the display of plots or analyses to show in this particular way. So it's really helpful for ordering our categorical variables in ways that might be less default, because R will try to do things alphabetically and that sort of thing. So in this example, we're just going to have a simple vector here where we have a couple, a few colors, yellow, red, blue. And if we check the class of this, it'll say that it is character. If we want to coerce it or change it into being a factor, we can use the factor function. This is slightly different from what we've seen in the class module where we did as character as underscore numeric. This is a base R function. It's quite nice, and it works really similarly. We'll talk a little bit about the differences and how we can make these. So let's try that over here. I'm going to make a new chunk, and I love in older versions of RStudio it wouldn't preview the color for you, but now it's like you could not ignore it that there's a preview for color if you can see the color. All right, so by default, we'll see that this is a character. And if we change it, we make xfact, which will be a factor version of x. And we say class of xfact. Notice using the factor function there, we'll say it is a factor. So factors have levels, and those describe the order in which there's some sort of meaning or the way that we want them to be ordered. So if we take a look at our order here, we'll see by just typing in the factor name, it'll display what the vector is, but it will also show the levels. And we'll see here that the levels are blue, red, yellow. And it chose that by default because it does it alphanumerically. So because we're dealing with characters, it chose to do it alphabetically, blue, red, yellow, that first letter. So let's see if we get the same thing over here. Actually, I'm just going to take it down here. Yes, indeed, we see the levels print out blue, red, yellow. We can also use a levels function if we specifically just want that. So we can say levels xfact, and it will give us the levels, blue, red, yellow. There's a really handy package called ForCats. It's got a really cute hex sticker if you like cats. There's a bunch of cats in a box, which I hear is something that they really like. I'm allergic to them, so sadly I can't hang out with them very much. But it's a really useful package for working with factors. So there is also this as factor option that we can use, and it's part of ForCats, and this comes with the tidyverse. But it is not going to do things alphanumerically. It is instead going to order things by first appearance in your data. So the default behavior for both of these is a little bit different, and either are fine, but it just sort of depends on what's useful for you. So let's try that in our example here. Again, when we use as factor, the class still shows up as factor. And if we look up xfact, this time we're going to see yellow, red, blue, because yellow came first, red came second, and blue came third. So slightly different behavior here. And here we're just seeing that together, that the levels are a different order when we use factor versus as factor. Okay, so now we're going to work with some real data to try to understand how to use this in a data frame and why this might be useful. So we're going to use that ER heat visit data from Colorado again. We're going to use read_CSV and that URL in quotes. And I already have that here. And if we take a look at that data, we'll see that we have year information, age information, rate information about the rate, and visits. So this is slightly different from what we've seen with this data set before. We had year information, but not necessarily age. So we've added an age element here. And we no longer have county information. But this is helpful because this age variable is something that we probably want to have ordered in a sensical way. And R is not necessarily going to pick up on that. So it will assume that we want everything in ascending order if it is numeric, but we want the order to be in the groups that we have here. And this happens, sometimes R gets it all right and all works out, but occasionally you need to tweak it, or you just would like to tweak it based on the way that the results plot or show in the analysis. So we're going to take a random subsample just to make this a little bit smaller. So we're going to use that set seed function. Remember, just a random number here that specifies how our slice sample is going to work so that everyone gets consistent results. So we've done that here. And so I had 60 and now I have 32 rows. Okay. And I'm going to make a box plot first of just what this looks like. And notice that 15, because 15 starts with a number that's smaller than 5, it ends up being interpreted by R as being numerically the second option. But this is not very easy to read if I want to see how things compare across age, because I have the 5 to 14-year-olds over here and the 15 to 34-year-olds over here. So just to recap on our ggplot, because now we know how to do that. We told you how you can have this mapping argument. It's not required. And we have the AES mapped to our X with age, and our Y variable is rate. And we're making a box plot. We're using theme black and white. And we've asked for all the text to be size 12 because we want you to be able to see it. So we'd like to reorder this because it's not really the optimal way for us. And to do that, we can use our mutate function because we're going to modify our age variable. So if you look at our data, we have this age variable. If we take a look at it, just as is, we'll get the Tibble information, which has conveniently the class information telling us that this is a character. Or of course, we could use Glimpse as well. It would also give us that information. Okay. But so to change a column or a variable, we always have to use mutate. And we're going to use the age variable is we're going to overwrite it. And we're going to use the factor function to change it to a factor. And of course, we're using the original age variable as our source. And we're specifying the levels. Wow, I can't say the word levels. That was bizarre. We just need a comma and specify that argument there. And because it's a list of things, we're going to need that combine function. Okay, so let's take a look at that over here. So we're modifying the age variable or overwriting it to become a factor, and we're specifying these levels. So we're going to want 5 to 15 first, to 14, and then 15 to 34, etc. So we'll run that, and we'll make a new object called ER visits age factor, or FCT. And we can pull out the age variable and take a look at the levels using the levels function, and we'll see that we have indeed fixed them. And just for comparison's sake, I'm going to also use the original data so we can see it's going to be unhappy about that because it's not a factor. So it's going to say there are no levels for the original version, but in this version, we have specified levels. Similarly, if we looked at the data using Glimpse or something like that, now we see that it's a factor and it was a character. Okay. All right. So what does that do for us? How does that change things? So we've noticed that we have this small change just looking at the data. That's all we see so far, really. But when we do subsequent things, like we try to plot the data, we'll see that it has changed the order. So all we're doing now is just using the different object to start with, but we have the same exact code for our plot. And now we see that we have the order of age in the groups that we want. So if we want to see them back to back, let's make this the subset. That was our original data. In the subset data, we have 15 first, then 35, then 5. And in this new version, we have it fixed, where 15 is in the middle. Okay. And this is also useful when we're arranging. So it's going to arrange based on the levels that it thinks it needs to do. So if we use the raw data, we don't have any specified levels. So it's going to order it exactly in the way that it ordered the plot, with the 15, because it has the lowest digit in the first place, as the second age group. But when we use the factor version, so we're using the factor version of the data, notice it orders it in the correct way. 0 to 4 and then 5 to 14, which is nice. So this could be really good for, summarizing our data or doing data analyses. We want to have it printed out in a way that's nice. So here's another example. Here, if we make a summarized sum of all the visits for the different age groups using our summarize function. So first we're grouping by age to make sure that we have those individual groups. And then we summarize and make a new variable called total visits, which is equal to sum of the visits column. So sum of this column, we're summarizing this column. We will see that it prints it out in that same order with 15 as number 2. But if we use the factor version, it will print out 15 as the third group, and it will put 5 to 14 as the second group. And this is nice because it's easier to tell here, oh, okay, we get a bit of a jump here from 0 to 4 to 5 to 15, but it really gets much bigger as we increase in age. Whereas here, I'm like, wait, they have a jump and then it goes back down. It's harder to tell what's going on. So yeah, it can be really nice to be able to plot our data in the way that we want the order to be. So what if we wanted to order age actually by increasing rate? So right now we have it ordered by age, but what if we wanted it so that the box plots were arranged based on the y-axis? So we could easily pinpoint which one's the lowest, which one's the highest. Well, there's a really handy function for this called factor reorder, and it is part of the FORCATS package, and it has a fairly simple format. There's one little tricky part, which is the function that we're going to summarize by. But we basically specify the column we want to change and the column we want to change by and in what way. So we'll see an example here. So here we're going to make a plot where we're arranging the box plots by rate. And to do that, when we specify what our X data is, we can actually just on the fly change age to be a factor, reordered. It's already a factor, but reordering the factor so that age is ordered by rate based on the mean of rate. So it's going to look for the mean of each age group for rate, and it will order the x-axis in that order. So notice we have now a different order. We see that 15 to 34 is the age group with the highest rate of ER visits when it's very hot. And that's a little bit harder to discern from this plot, right? I have to kind of think, wait, what am I looking at? Where are these ages? It's really easy to read which groups are the second highest and the third highest, etc. So this is the only part that was added here. Instead of just putting age, we put factor reorder age by rate using the mean. And we can add a dot descend equals true argument to go in the opposite order if we wanted to. So that's just inside our factor reorder function. And then FORCATS can also help us reorder things as well. So if we look at the levels, we can actually change with factor reorder to mutate a variable. In this case, we're not doing it in ggplot itself. We're actually mutating it using the factor reorder. So we have to already have a factor to work with. So we're using the factor version of the data, but we're reordering it so that if we want to do subsequent analyses, we'll continue to have that order. So when we look at the pulled levels, we see that 15 to 34 is now, the last age group, whereas it was the third age group. Finally, there's one last function from FORCATS that's kind of helpful. It's called factor count, which can give us the count and proportion if we use the proportion equals true argument to give the information about what fraction of each age group or each level for the factor do we have. So it's saying that 4 of the rows are in the 0 to 4 age group, and that's a proportion of about 12% for part 1, 2. All right. And then we have more data here for these age groups. That's about 20%. This is 25%. So that can be helpful. So gut check. Why is it useful to have a factor class? Is it because it helps us check the factual accuracy of our data, or B, because it helps us change the order of variables in case we want to have a different order or the order has meaning? Very good. Yes, the answer is B. What does the factor reorder function do? It helps us reorder a factor based on the values of another variable, or it helps us reorder a factor based on a random change in the order. Yep, it's A. So we saw that here. It helped us reorder age based on the mean rate value. So it reordered age based on the rate column. It took one variable and reordered it by a different variable. All right, in summary, the factor class allows us to have different orders from just simple alphanumeric for categorical data, and it helps us to organize data in the way that we might want to. We can change data to be a factor using mutate if we have a data frame, and because we always use mutate if we're modifying or creating a new variable, and we can use either factor or as factor to do so, and they have just different defaults. And so as factor is going to do by first appearance. Factor, which is base R function, is going to do alphanumeric. Factor can specify the levels with the levels argument. You use levels equals, and then you list in a vector using the combine function the levels that you want. Be careful to make sure that the levels match the unique values in that variable. If it does not, you will get an error. And factor reorder helps us reorder variables by the values of another variable. And we can do subsequent arranging, summarizing, analysis, and plotting based on the order that we specify for our factor.
Last lab of the day. All right. Let's go ahead and load the data. So there's some select and cleaning steps for the Cal EnviroScreen data we've worked with quite a bit. So let's go ahead and load that and make sure we have tidyverse loaded, of course. All right. And let me do, might be a mistake here. Okay. All right. So in case you're following along in creating the data, make sure you use the in operator. Okie dokie. So we want to create a box plot. So we had a lot of fun creating some visualizations. We're going to keep doing that. But important thing here is going to be like the order and things like that. Okay. So let's say we want to do ggplot. We're going to use that CES data it's like a little bit of a subset. And our aesthetics are the contamination threats and the different counties. And so we want counties on the x-axis and contamination threats. And again, this is going to set up our plot, but not really add any flavor to it. So we'll want to add geom box plot. All right. And so we're taking a look here. How has it ordered the counties on that x-axis? Noticing anything here? How are these counties ordered? Yeah, exactly. They're alphabetical, right? So it's going from A, N, S, and then V. So, that might be fine. Maybe you're not too worried about kind of the display here, but, as you have more counties, maybe that could get more important. You might want to order them or color them by region or do that kind of thing. So let's continue on. We'll use count to count up the number of observations for each California county group. And so to do this, we could just take the data, we could pipe that in to count, and then take a look at California County and see how many entries I have for each. So, taking a look over here, how many, and this was originally like census areas, right? Census tracts. So I've got a lot of census tracts in Napa, for example, San Francisco, but looks like I have a lot fewer for Amador County. Alrighty. So let's make California County a factor to make it so that we can reorder these counties. Reorder this variable so the order is now San Francisco, Ventura, Napa, and Amador. So going from maybe the most census tracts or N number of rows to the least. Maybe that order is something that we are excited about and want. So what I'm going to actually do is create a vector of the order that I want. I find this to be a little bit easier for me. So I separate the steps out a little bit. So first make the order, and I'm going to tell it the order that I want. Right. So let's do San Francisco, then Ventura, then Napa, and then Amador. All right. And then I actually want to do the mutating, right? So I want to actually update that column so that it is a factor. So right now, if we take a look, the county is character type. I want it to be a factor here. So let's update it. So let's take a new object. We'll call it CES fact, and we'll take the data and let's pipe that into the mutate function. because we're going to update that column. We're actually going to mutate the contents of the column so that it is a factor. We're going to replace California County. So we can do that by giving it the same name as before. And we can use the factor function on California County. And so what is this going to do? So if I just run this here and then glimpse CES fact, and it would help if I spelled it right. It's a factor now, but the order is going to be just, alphabetical. It's the previous order. I didn't actually specify the order. So to make sure that it's the order I want it, I'm going to need to do levels, and I'm going to make it county order, the object that I specified up here. Just a variable, a stand-in for, writing that out right here. And let's try again. Let's take another look. So same kind of values here, but if I were to look at those levels, it would be, it has different meaning in terms of like what level comes first. And I could even investigate that a little further. And I can see that it's a factor with levels, San Francisco, Ventura, Napa, and Amador. These are the levels that I provided up here, not the default. All right. Well, let's redo the questions 1 and 2, 1.1, 1.2, using the factor data. Let's see a different ordering here. So we had done ggplot. You can certainly copy the code over. That's fine. Plus geom-boxplot. Okay. Maybe I want the color to be, or the fill, right? Because we're doing box plots. Just adding some additional flavor. All right. And then finally, let's take a look at the count table. And I can see that one's reordered too. Now it's by descending n.